Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on momentum conservation from October-November 2021 paper 2-1. I said this is a typical type of question because this type of questions are very common in past papers. And in this lesson, we will not only answer these questions, in fact, I will teach you how to answer this type of problems. For part A, simply we need to define what is momentum. And simply you can remember this one. Momentum P is equal to mv. So in your answer, you have to write down the product of mass and velocity, not the product of mass and speed. So momentum is simply product of mass and velocity. Momentum is a vector, so you have to write down product of mass and velocity, not speed. And this question has 1 mark and this is B mark. It simply means that this has to be in your answer. For part B1, we need to calculate kinetic energy of ball X before the collision. And for ball X, the speed of ball X is given and the mass of ball X is also given. Now simply we need to calculate kinetic energy. So simply we can say kinetic energy is equal to 1/2 mv squared. We have the value of mass, we have the value of the speed in this case, and simply we can plug in these values and we can calculate kinetic energy of ball X. Mass of ball X is 0.24 kgs and the speed of ball X is given, that is 2.3 meters per second, and it is square. And if we solve this one, your final answer will be 0.63 joules. We are using 2SF because this raw data also has 2SF. So our final answer in this case is 0.63 joules. This question has 3 marks. The first mark is if you have written this formula. And the second one, if you plug in values, you will get second C mark. And this is answer mark. If you got the right answer, you will get full marks. For second part, it is given to us the area enclosed by the lines and the time axis in figure 2.2 represents the change in momentum of ball Y during the collision. We need to determine the magnitude of the change in momentum of ball Y. Now, first thing we need to understand is that why this area, this is equal to change in momentum. If you look at these two balls, we have ball X, so this is ball X, and here we have ball Y. So when these two balls, they are in contact, they collide with each other, so they will exert force on each other. Means this ball X, this will exert force on Y. So this will exert force on Y by X. So this will be the force on Y, and Y will exert a force on X. So this will be the force on X. But these two forces, they will be equal in magnitude but opposite in direction. So this is a very important point we need to understand. Now if we multiply this force, as we simply understand F net, this is equal to change in momentum over time. So this is delta P over T. Now delta P from here, simply you can see that delta P simply will be equal to F times T. So that's the reason the area under this line, this is representing the change in momentum. So this is over delta P. So this is one concept you need to understand. Now simply we need to calculate area. So area in this case, this is equal to change in momentum. So simply we can say the change in momentum in this case, this is equal to area. But if you look at the shape, this is a triangle. So simply we need to calculate area of triangle, and area of triangle is simply equal to 1/2 time base, means the base of triangle, and we need to multiply this one with height of triangle. Now the first thing we need to find out the base. The base is simply equal to 5, means 5 minus 0. So simply we can say base in this case is equal to 5. But the unit of time is milliseconds. So we have to multiply with 10 to negative 3. Next one is the height. So height you can find from here. So this is the height of this triangle, and this is equal to 240 newtons. So simply we have to multiply this one with 240 newtons. Now if we simply calculate, our final answer will be 0.60 newtons second. So our final answer is, in this case, change in momentum is 0.60 Newton seconds. And this question has 2 marks, and the first mark is for this one. If you have plug in right values, you will get C mark. And the second mark is answer mark. If you got the right answer, you will get 2 marks. For this question, we need to calculate the magnitude of the velocity of ball y after the collision. But this question is a little bit tricky one, so let me explain to you. So our main focus in this case is ball y. So we have to focus on this one. For this question, we have already calculated the change in momentum, delta p we have calculated, that was equal to 0.60 Newton second. We have already calculated this one. Now, if you look at these two balls, ball y and ball x, this is momentum of these two balls before collision, means the momentum of this ball and momentum of this ball. And this surface is frictionless and there are no any external force, means no net external force is acting on this system. So this is our system we have defined. This is our system. And so it means that there is no change in momentum of the system, means the total momentum of the system remains constant. If you look at the momentum of this ball, the momentum of ball x, this is greater than momentum of ball y. So the net momentum in this case, this is to the right. So the net momentum is to the right before collision. So it also means that the net momentum after it also has to be to the right. So the net momentum has to be to the right. So this is very important point. This is what you need to understand. So you can simply say that in this case, the initial momentum is to the right. So the final momentum also has to be to the right, means the final momentum of the system. So if we have understanding of this now, so when these two balls, they will collide with each other, they will be force on this ball by this ball x, and that force will be to the right. So I will simply write down the force on ball y by x. This force will be to the right. So this ball, in fact, this will go to the right. So simply we will say the final momentum of ball y, it will be to the right, and its initial momentum is to the left. Now question is asking us to calculate final momentum. So simply we can write down delta p. In this case, this will be equal to p final minus p initial. P final is to the right, so we have to take one direction as positive. So let's say to the right is positive. If to the right is positive, so to the left, that will be negative. So now simply we need to plug in values. So here we can plug in values. Delta P, this is equal to 0.60 Newton second. So this is 0.60. Let me rewrite this one. So change in momentum we have calculated, that was equal to 0.60 Newton second. And P final we can calculate from here. So P final is positive because this is to the right and we assume to the right is positive. And P initial, this is to the left. So this will be negative. So this will be negative. And we can multiply velocity in this case with the mass. So this will be the momentum of ball y before collision. And now simply we need to simplify this. If we simplify this one, we can simply write down this is P final and this will be plus. We have 2.3 times 0.12. We need to calculate P final. So P final from here we can say that this will be 0.60 minus 2.3 times 0.12. If you do these calculations, final answer will be 0.324 Newton second. And this is the value of the final momentum of ball y. But now we need to calculate the final velocity of ball y, means the velocity after collision we have to calculate. So we can simply write down final momentum. This will be equal to mv, the momentum after collision, and this is 0.324. We need to find v from here. So simply just divide by mass. So this is 0.324. We need to divide by the mass of y, and mass of y is 0.12. So this is simply divided by 0.12. So the final answer in this case is 2.7 meters per second. Mean this ball y will go to the right with this velocity, and this is the magnitude of that velocity. So simply our final answer has to be 2.7 meters per second. This question has 2 marks. If you have got final momentum right, you will get 1 mark, and this is C mark. And if you got right value of the velocity, you will get second mark. For part C, on figure 2.3, we need to sketch the variation with time t of the force Fx exerted on ball X by ball Y during the collision in part B. First of all, let's try to imagine that what is happening. Imagine that you have this one ball, this is ball X, and this ball is colliding with another ball, and this is ball Y. So when these two balls, they will collide with each other, they will exert force on each other. So the force on Y, we can simply say the force on Y by X. There will be also another force on X by Y. So we can say this is the force on X by Y, and these two forces, they will be equal in magnitude and opposite in direction, because they are action and reaction forces. So I will simply write down here Fx, this will be equal in magnitude to Fy, but opposite in direction. You can also feel this one by clapping. When you clap your hands, you will feel the force on both hands, and those forces will be equal in magnitude but opposite in direction. So by clapping, you can also feel this. Now we also need to understand the time of contact, or the time they exert forces on each other. Let's say this time is Tx. For time Tx, the force is exerted on ball X by ball Y. This will be equal to the same time for ball Y as well. Means the forces will act on these two objects for the same period of time. From here, we can also say that delta P for X, the change in momentum of X, will be equal to change in momentum of Y, because change in momentum is simply equal to force times time. So from here you can also say that impulse on X is also equal to, I will simply say impulse X, that will be equal to impulse Y. So impulse is also the same, because impulse is also simply equal to change in momentum, or simply you can say this is equal to force times time. So you can see from here forces on two bodies are the same, time of contact is also the same, change in momentum for these two bodies is the same. So this is our third point. And the fourth one, you also need to understand impulse for both bodies also is the same. So very important concept, they can ask you next time in a different way. Now this question is simply based on our first concept. Force on two objects is the same in magnitude but opposite in direction. Now simply if we go back, we have already done actually this question, because in the question it was given to you force acting on Y. So now it has to be just reflection of that force, means the reflection of that graph. So let me show you that graph again. So the first thing, you can simply imagine, this is how you need to sketch this one. So this is the force on X during collision, and this is the reflection of the force on Y, because these two forces, they have the same magnitude but their direction is opposite. So let me clean first and show you the force acting on Y. So this is the force that is acting on Y. So if you look at these two graphs, now simply you can imagine that force on X is equal in magnitude to force on Y but opposite in direction. So this force here at this point is 240 newtons. So at time 3 millisecond. So here this force also has to be, you can simply write down 3 comma negative, this is 240 at this time, and here 0, so 0 comma 0, so this is 0. There is no force here. This is after collision and this is before collision, so this is also 0. So this is how you need to sketch the graph. So if you have done this one, you will get full marks.